Hi, welcome to our first video for 3.5, transformations of exponential functions. If you remember in the last unit, we learned how to do all different types of transformations for functions. Some of those functions were x squared or root x or 1 over x. Well, now we're going to apply those transformations to exponential functions. And if you remember, I said that these rules that we were learning, they can be applied to any function, even ones we haven't learned yet. Well, now that we've learned the new ones, like exponential functions, we're going to go ahead and apply them. The rules stay the same, which is really, really nice. So if you remember, we had the general form y equals a times f, and then we have k times x minus d plus c. So this is a general form showing all the transformations that can be done to some function f. In this section, we're going to be using exponential functions as our base function f. But let's just recap what all these parameters do. So these are all listed one at a time in here, which is kind of a nice way to look at each one on their own. Together, it ends up looking like this. So let's do a quick recap here. So we'll do the vertical ones in blue. So all the vertical transformations. So the first one here, this value c, whenever we add c to a function, it's just going to end up being a vertical shift of c units. Okay, and if c is positive, it goes up. If it's negative, it goes down. Next, if the function is multiplied by a value, well, that can cause a stretch, a vertical stretch or compression. Depends on the size of a. By factor a. So if a is greater than 1, it stretches up. If it's between 0 and 1, it gets vertically compressed. And if it's negative, it gets reflected. Okay. So I'm not writing down all the rules, but I'm just doing a generalized statement of them. So this one here, so if we subtract d from x, remember this is done inside the bracket with x. So these ones change the input before the function is processed. That's why these are horizontal. These ones are added outside after the function is processed, right? That's why those are vertical. So if d is subtracted from x, that's going to cause it to shift horizontally d units. And the value of k, if we multiply x by k, that's going to do a horizontal. It's either going to be a stretch or compression. Remember, this is the opposite as a. It does the reverse. So because it's going to stretch or compress it by a factor 1 over k. So if k is like bigger than 1, this is going to work out to a small number. So if this factor is between 0 and 1, it's a compression. If this factor works out to be greater than 1, it's going to be a stretch. How could this be greater than 1? Well, that means k needs to be a small number, like a half. So if you had a half in here for k, this would be stretched by a factor of 2. So it would be a horizontal stretch by factor 2. Anyway, we'll be going over these again as we do the examples, but that's basically it. How would this show up for an exponential function? What would the equations need to look like? Well, if f of x, let's say our base function was b to the x, b representing some base, well then my equation, if I follow this here and apply it to this base function, it would look like this. We would have a times the base, but this time my exponent, instead of it just being x, I got to include all these transformations because this is the new x. So this has to go up where the exponent is. So it's a nice thing. This square bracket will always be the exponent. So we'll have k, x minus d, close it up, and then we have plus c at the end. So you can see a is multiplied in front, c is added at the end. K and d will always be up in the exponent. And b just represents some base. So we're going to do all different sorts of examples. So sometimes our base is 3, like it is in this example. The next page, the base is 4. So the base can really be anything as long as it's not less than 0 or 1. Okay, so let's go ahead and start our first example. It says sketch the graphs of the following functions using the graph of y equals 3 to the x as the base. Describe the effects, if any, on the asymptote, domain, and range. Okay, so let's do part A here. We'll do this one in blue. Okay. So this means this new equation means if this is the base and this is the new one, it's just a vertical shift that's being applied. We could say c equals -4. Therefore, shift down 4 units. Okay, what is this going to do to the point? Well, the base function xy is going to move over to xy minus 4. That's our vertical shift down 4 units. So we already have the graph here for y equals 3 to the x. That's the base graph. And then we're going to apply this transformation to it to get the new one. So let's mark off some points here. We got 0, 1. Up here, we got 1, 3. And up here, yeah, there's a point there, 2, 3. Okay, and this graph keeps continuing up, right? This is y equals 3 to the x. So applying this rule here, we can do the new one in blue. All those points need to move down 4 units. So this first one, 0, 1, let's write them out. 0, 1 is going to become 0, 1 minus 4, which is just really going to be -3. Okay, you guys get the idea. So this would become 0, -3. So this point just moves down 4 units. Same with the next one, 1, 3. Subtract 4 from the y value. So 3 minus 4 is -1. So we got a point there. And then 2, 3. Oh, 2 is not 3. I don't know why I wrote that up there. Sorry, guys. That needs to be a 9. Let's switch that real quick. 2, 9. Okay, that's going to move to 2, 6. Because we got to, or sorry, 2, 5, because we're taking 4 away. So 9 minus 4, 2, 5. So 2, 5, that would be right here. Okay. What about the other points? You might say, Mr. A, what about these ones? Well, let's go ahead. Let's just, if you want, we can take one of them and we can move it down 4. Okay. The other thing is, I know that this graph has an asymptote. So I'm going to draw that in here. Okay, the nice thing is when we apply the vertical shift down 4 units, the VA also has to move down 4. So the horizontal asymptote is now going to be at the equation y equals -4. Okay, so I'm going to add that in here. I'm going to say the horizontal asymptote shifts down 4 units. So that makes it really nice to graph too. As soon as you know you get to bring this HA down to here, and you got a few points, you could just fill in the rest. So I guess that's easier than trying to find one of these points to move it down. So I'm just going to keep that nice and close and then slowly pass through the points. And that's y equals 3x minus 4. And you can really see when you compare this to this, it just means a vertical shift down 4 units. So it asks us to state any effects on the asymptote. So I did that right here. What about the domain? Does the domain change? It doesn't look like it because we still use all the same values for x because this function keeps going this way. There's no restrictions, so we'll say no change to the domain, let's say. And what about the range? Well, the red graph, the range is everything above 0. Now that we move the HA down, it's going to be everything above -4. So we'll say range changes from y is an element of R, y greater than 0, to y is an element of R, y greater than -4. Notice what happens. This is the value of C when it gets shifted. So the horizontal asymptote and the range get affected by C. Okay, now we get to look at some other types. So this is going to be a little bit tight, squeezing all this in. I'm going to change to green for the next one. Oops. So we're going from 3 to the x to y equals 3 to the x minus 2. So you can see my exponent change from x to x minus 2. So here we're subtracting a value from x from up in our exponent. So I know this has to be the d value because this isn't like minus 2 at the end. This is 2 taking away x before you process this whole thing. So this is going to be a horizontal shift 2 units right. So I can say d equals 2. Therefore, horizontal shift to the right 2 units. And yes, it's okay if you want to write that down that way. A little bit of a shortcut for describing the horizontal vertical shifts, and that is fine. How are our points going to change? Well, we have our main points, x, y. This is from the base graph. Remember, we had 0, 1, and then we had 1, 3, and we had 2, 9. Well, when we map over to the transformed one, we're going to have, we're shifting to the right 2, so it's going to be x plus 2, comma y. So we're just adding 2 to x, so we'll have 2, 1, 3, 1, 2 plus 2 is 4, so 4, 9. Okay, so I just added 2 to these values in order to get this here. All right. So I'm going to have a point here at 2, 1, another point at 3, 1, and then another point at 4, 9. That doesn't look right. The one at 3, 1 should be here. 3, 1 should be right there. Okay. So all the points are moving over just 2 units to the right. Okay, exactly 2 units. So if you want, you could even take one from over here and move it over to 2. That might not be a bad idea. Take this one and move it over to here. Okay, this help us get a little bit of a better graph. So is our horizontal asymptote going to change? No. During a horizontal shift, this horizontal asymptote is still going to stay along the x-axis. So that's fine. We'll leave that here. We're just going to draw that there, going through like that. And this one is y equals 3 to the x minus 2. Make sure you include your arrows on those functions to show that they keep going. All right, so in this one, the horizontal shift, did it change the asymptote? So we'll say no change to the asymptote. Does it change the domain? No, it doesn't change the domain. We still use every value because this keeps going this way and this one keeps going that way. So no change to the domain. And what about the range? Does the range change? Well, no, we didn't move it vertically. So no change to the range. So it actually had zero effect on those three, the horizontal shift. Okay, we might be able to squeeze this last one in. It has a couple things going, so might be better for us to make a little more room. Okay, and now we're gonna do this one in pink. So for part C, my y equals 3 to the x is now turning into y equals 3 to the x plus 1 plus 3. So I can see there's two things happening. There's the horizontal shift and there's the vertical shift. Notice none of these had any stretches or compressions. Okay, there's no numbers written in front of any of these or nothing with the x. There's no multiplication happening. We're always just adding or subtracting either horizontally or vertically at the end. Okay, so let's write this out. So I can see d is equal to -1, because remember it's always the opposite sign up there, because the form is x minus d. So what does that mean? This just means shift left 1 unit. And I also can see that c is equal to +3, so we shift up 3 units. How are my points going to change? Well, my points x, y are going to map over to, if I'm shifting to the left, it'll be x minus 1, and if I'm shifting up, it'll be y plus 3. So we'll have 0, 1, 1, 3, 2, 9. Okay, those all map over. 0 minus 1 is -1, 1 plus 3 is 4. 1 minus 1 is 0, and 3 plus 3 is 6. 2 minus 1 is 1, 9 plus 3 is 12. So those are my 3 points. What do you think is going to happen to the horizontal asymptote? Well, if we're doing a vertical shift up 3 units, then it should move up 3. Why don't we go ahead and plant that up here along the line y equals 3. Okay, this will always, basically what this is telling us is it's always going to be y equals c, whatever is added, the vertical shift. And these points here, -1, 4, that's right here. 0, 6 is here. 1, 12. Oh, look at that, it just fits. And draw our curve through. That's y equals 3 to the x plus 1 plus 3. What are the effects on the asymptote, domain, and range? Well, the horizontal part doesn't affect anything. So the domain stays the same. And we can see that the asymptote and range change by, I can say 3 units up because of the vertical shift. So let's just write it out real quick. The range is going to be y is an element of R, y greater than, notice everything is above 3 because we never reached 3 because of the HA. So we'll just say y greater than 3. And then our asymptote is also going to be at the line y equals 3. If you want to shortcut it, you can write HA for horizontal asymptote, and you can say at y equals 3. Okay, so that's it for the first example, showing some of the just horizontal and vertical translations that could be done to a base exponential function. Notice it's the same rules as before. Take your base function, get your base points, and then go ahead and apply the transformations to them. Okay, that's it for the first video. I'll see you in the next one.